So the first thing that we'd like to do is figure out what's going on over here with my scale. I need to know in the x direction and the y direction what's the value for each one of these divisions that are behind the signal. That's like a graph on graph paper, right, where normally you'd be told, well, this is 1, 2, 3, 4, etc. So in this case, that information is always down here at the bottom. We're going to be ignoring channel B because for these problems we're not using channel B. Here is my x values, so I know in the x direction it's going to be 10 milliseconds. That's right here. Every division is 10 milliseconds, and in the y direction every division is going to be 5 volts. So my first task is to find the peak amplitude. So I want to know what's the highest that this value gets above 0. So this is my 0 line. I want to know, this is my highest point. How tall is the peak? So you can count the number of boxes. Now I know sometimes it's hard to see these little dotted lines, but right here, if you notice, that's 1 box, that's 2 boxes, so we can say that it is 2 divisions tall, and then from our scale we know that each division is 5 volts per division. And if we multiply that together, we should get our peak. Algebraically, right, the divisions are going to reduce away, and we're going to end up with 2 times the 5 volts for a total of 10 volts. Next, we're asked to find the peak to peak amplitude. So we need to pick a maximum point. So here's one maximum and a minimum point, and we need to find out, well, how tall is this from peak to peak? So again, the boxes or the grid lines help you out. So that's 1, 2, 3, 4. So from peak to peak, it's going to be 4 divisions. And again, it's 5 volts per division. And when we do the arithmetic, divisions are out. 4 times the 5 volts will get me 20 volts. Now most of the time, most of the graphs that you'll be looking at will be symmetrical, so it'll be the same distance above as it is below, but it is important that you show your work because you never know. Sometimes people make silly errors, and if I can clearly see that you know what to do and that maybe you made an arithmetic error, that's minor compared to knowing what to do in order to find the 2 amplitudes. Alright, after amplitude, you're asked to find the period. And the letter that we use for period, because it is a value of time, is the letter T. So we want to know how long does it take to complete a full cycle. But in order to figure that out, we need to know what is one complete cycle. I suggest you find a division line and pick that as your starting point, and then trace the graph for one complete cycle. And I'm not too good at lining this up, but you get the point that this would be one complete cycle. So I really want to know this distance from start to finish. How much time does it take to complete one whole cycle? So if you notice here, takes one box or one division from start to finish. So that's one division. And from the grid, from the time-based section, we know that it's 10 milliseconds for every division. And when we work that out, the one division and the one division, that leaves us with 10 milliseconds. So that is how long it takes to do one complete cycle. And that's no matter where you picked. If you had picked to start here, one complete cycle would go to here. And that's still one complete box, even though we start in between the grid lines. It's just easier to see if you could start on a grid line, and of course it's easier if you end on a grid line. And then the fourth one is, once you know the period, then the frequency is the reciprocal of that. So this is a formula that you need to know. But what's going to be important is that I have to know that 10 milliseconds needs to be converted to regular seconds. So the decimal point is here. Milli is 10 to the negative 3. So since I moved in the negative direction, now I need to move it 1, 2, 3 times. New decimal point. Got to fill that in. So in regular seconds, that would be 1 over 0.01, just plain old seconds. Put this in the calculator, 1 divided by 0.01, and you should get 100 hertz.